What?
Okay, so we're going to get going. We're going to start with Unit 2 here, and Unit 2 is the trigonometry unit. Some of it's based off of what we did last semester in Foundations 20, so there will be some sine law stuff and some cosine law stuff. But the first bit of it is working with Cartesian planes, so with your x and y grids, okay? And we're going to be drawing angles, and we're going to actually look into why we have certain values for certain things, right? Like now you'll discover why, if you hit sine 30 on your calculator, it comes up as 0.5. All right, we're going to start solving all this stuff, and it ties in nicely with what you'll take in pre-calc 30 when you take trigonometry there. All right, so it does build off of it, okay? Now, ideally, you'll remember some of this in September. I know the 12s this year didn't, but that's fine, okay? So we're going to dive right into it. So what we're going to do today is we're going to be drawing angles on a Cartesian plane, all right? So with your x's and your y's, all right? Like so, all right? Now, normally you would draw an angle. You don't have to take this down, right? Something like that. And there's your angle. You know what? Maybe I'll do that in a different color. Now what we're going to do is we're actually going to draw it on the plane. You always draw your bottom line right off your x-axis. And then draw your angle off of there, like so. And your angle's measured here. Now this here, all of this here is known as an angle in standard position, okay? And for that to work, you have what's known as your initial arm. You have your terminal arm. Okay, you always measure the angle between the initial and the terminal arm. And both arms come off the origin, okay?
I'm not having a knuckles every time you do that.
Nah.
All year.
What?
She did that all
What
year.
did you just say?
She did that all last semester too.
I don't know.
When you were teaching us the last time.
You hit the right
textbook and you right in front of my face. You take your knuckles.
You hit the right spot, it doesn't hurt. Okay. Now, each angle or each one of these quadrants, I don't know if you guys have taught you this before when we did Cartesian planes, but like there's the 4 quadrants, right? Like this is quadrant 1, quadrant 2, this one down here is quadrant 3, and this one's quadrant 4. Okay. And we'll be coming back to that time and time again in this unit. 1, 2, 3, and 4, okay? So it just goes clockwise around.
This way.
Counterclockwise. Whatever. Good thing that's recorded. Okay. Now, to measure an angle, it's really straightforward. Draw your initial arm, draw your terminal arm, and then whatever that measurement is. Like, let's say this is 120 degrees. Okay. Or if we did another one, let's say we had a line coming off like this. We could say that this is 210 degrees. Okay. In this unit, it'll all be just sketches. Okay, we're not going to have precise angles, or you're not going to be measuring precise angles. All right, these are just drawings to represent. Okay. So that's how you draw on a Cartesian plane. These are standard position angles. Yeah, Mike.
Does the angle always open up counterclockwise?
Yes, you always measure off the x-axis. Sorry, I should have said that. Off the x-axis and come counterclockwise. Okay, always. If you do go the opposite way, you can go clockwise. Close. We would say it's a negative angle. Okay, so this is positive 210. That would make this negative 150. Okay. Good question. I don't think they cover negative angles here in the textbook at all. But yeah, if you're going in the opposite direction, it becomes negative, and then you would measure it this way. Okay, and you would know that this is, because coming from here to here, that would be 180. And this is actually like 30 degrees here. So you would know that that's 180 minus 30 is 150. And that's how you would figure that out. Okay, well, and that actually ties in nicely to the next part here of reference angles. Okay, a reference angle is any angle measured off the x-axis, okay? All right, it's an acute angle, okay? Okay. Reference angles, we're going to be using these quite a bit. It makes it easier to find trig values, which we're going to be doing here. So let's say, for example, I'm measuring a standard position angle. And let's say, once again, let's go with the angle is 120 degrees. The reference angle is the acute angle off the x-axis. Okay? So this is bigger than 90. So it's an obtuse angle, right? So my acute angle then comes off of here. Put a little r underneath to represent the reference angle. So if this is 120, then my reference angle off the terminal arm to the x-axis,
60.
right, is 60. Okay. And you could do that off of no matter where the angle is, whatever quadrant it is. Like, let's say we have an angle here. Let's say the angle is 310 degrees. Then you could measure your reference angle here, and that would be 50 degrees. Okay? It's always the acute angle measured from the x-axis, and it can go either way. Okay? If you're ever measuring an angle in the first quadrant, and it's less than 90, then that angle is just the reference angle. Okay? So in here, I say they're just the same. Okay. Any problems with that so far? Cool. Right on. All right. So moving on. All right. So now we're going to look at some specialty triangles and get some values for sine, cosine, and tangent. Okay. So the two triangles that kind of get thrown about, they're the most famous triangles out there, I guess, is a 45 triangle and a 60-30 triangle. All right, have you guys talked about 60-30s or 45s?
No, I got 64.
A 45 triangle is basically, it's a right triangle, and the angle's 45. So that means this angle here then has to be
45.
right.
Oh my god, I'm going to start using that reference too.
So it's a 45 angle triangle. Now we don't say 45-45 because that's redundant, you just say it once. This is actually, the triangles we're going to talk about, these are the two triangles that are given out in geometry sets. Okay?
Oh.
Yeah. If you do, I guess you guys don't do any actually hand drafting anymore in PAA, it's all on computer, right? If you ever take like any sketching or AutoCAD or actual like drawing, not with just Google SketchUp, but like if anyone becomes an architect, you used to draw stuff with actual triangles. And you get big ones, and one would be a 45-45. Because a 45, 30, and a 60-degree angles, those are your three most common angles, besides a 90-degree. Okay? And what's nice about a 45-degree triangle is it's a does anyone know? Two angles are the same, so it's going to be
Isosceles?
right, isosceles. So these two sides are the same, right? Here and here. So what we do to make things simple with trig, the easiest number to work with is just 1, right? So if this angle is, or if this side length is 1, this side length is 1. All right, now let's say we wanted to find our hypotenuse. Because it's a 90-degree triangle, we can do that real quick using Pythagoras, right? So then c squared just becomes 1 squared plus 1 squared. 1 squared plus 1 squared is just 2. So you could say that c squared equals 2. And if you square both of them, c is just root 2. So this ratio works for anything now. If I have any 45-degree angle triangle, and let's say this length is 10, this length here would be 10 times root 2. And that'll give you the actual length. Okay? So if you're ever dealing with anything like that, this ratio holds up for anything now, with a 45-degree triangle. And what's nice about that is when you use SOHCAHTOA, these values are actually really nice to find.
I thought it was saw.
So, toa.
What did we use to buy some of those?
I think he used to say like SOHCAHTOA.
Yeah.
That's what it was. So
So if I want to find sine 45, I know sine is opposite over hypotenuse, right? Opposite. Doesn't matter. Like, let's say I'm using this. We'll reference this one here, okay? So this would be my opposite. This is my hypotenuse. Sine 45 is 1 over root 2. Cosine 45 would be my adjacent, and that's my hypotenuse, so it's 1 over root 2. And then tan opposite over adjacent now, 1 over 1. You just say that's 1. Now if you take your calculators out and put tan 45 into your calculator, guess what you're going to get? 1. Okay?
are you sure?
Mm-hmm.
Sweet.
That's where these values come from, is right here. This is what the Greeks figured out thousands of years ago.
Sine, not
Oh. What he said.
And if you put root 1 over 2 in your calculator, you would get sine 45. Okay? Okay, now for a 60-30 triangle, should I show you guys where they came up with the numbers or just give you the numbers?
Show us the.
I'll show you where they got it. We might need a little more room, but that's okay. Now for a 60-30, what they did is they started with a triangle like this. It was all equal. Okay, so everything was 60, 60, 60. Okay?
Should we write this down?
You can if you want. It's up to you.
Okay.
I'll show you, and then you can decide. And what they did is that they made every side, if it's an equilateral triangle, all sides are the same. So to make it easy, what they did is they just went, that's length 2, that's length 2, that's length 2. It's all the same. They could have used number 1, they could have used number 10. They went with 2, and I'll show you why in a minute. Now, what they did is this isn't a 90-degree triangle, right? So you can't use SOHCAHTOA, can you? So what they did is they drew a bisector down like that. What?
Because you said you can't use SOHCAHTOA, but you can use SOHCAHTOA.
Oh, so, All right. So what they did is they split it down. Now take this triangle down for sure. Once you split it, I should have left more room. You're gonna get a triangle like that. And here's your 90 degrees. This is 60. Now if I split this top angle in half,
It's 30.
and let's do 30. Okay. Sorry, that's a little messy. It's a little squished. I didn't give myself enough room. Okay. Now, we knew that this length here was 2. This length here has been cut in half, so it's no longer 2, it's 1. Like so.
A squared plus B squared.
Right, I can use Pythagoras again. This time I know 2 squared equals 1 squared plus B squared. Now I'm not going to show all my math this time. Take my word for it though. If I solve this all out, 2 squared is 4. 4 take away 1 is 3. Square root of 3 is just root 3 equals B. So this length here is root 3.
So it's 1.5.
What's that?
1.5.
No, square root of 3 is not, that's dividing it.
By 2.
3 divided by 2 is 1.5. Square root of 3 is like 1.73.
1.73.
Cool, 1.73. Leave it as root 3. In pre-calc 20, you guys need to get used to working with roots more. There's a whole unit on roots, so embrace them. They're not going anywhere. Okay? So, with all that information, I'm not going to sit here and break it all down again, but I'll give you all the values. I'll do sine 30, cosine 30, tangent 30. Okay? So sine, opposite over adjacent, if I'm dealing with 30, that's 1/2. Did I get that? Oh, good. Let's get it backwards. All right, cosine is root 3 over 2. And tangent is 1 over root 3. Oh. How are you guys doing for room? You guys got room?
Yeah.
Okay. So everyone got that written down?
Yeah.
Okay. Once you get them, I'm going to erase part of it and do the 60s.
Oh my.
Or if you guys want, try figuring them out. Put sine 30, cosine 30, tangent, or sorry, 60. Sine 60, cosine 60, tangent 60 beside them, and see if you can solve those 3.
Oh.
Okay? That's what you should have got based off of using the 60-degree angle. This would be your adjacent, opposite, and hypotenuse. All right? And these values hold up. If you punch cosine 60 into your calculator, guess what you get?
That.
Yeah, 0.5. So these are where the values came from. And then they sat down and they did it for every angle possible.
Why?
Why not?
Every weekend.
And what else were they doing?
Not be nerds.
For weekend, there's too cold to party.
Fair enough. You could do anything else. Buy onions.
Yeah, buy onions for your family.
Okay, so
Buy more onions.
what we're gonna do now is we're just gonna do some
Yeah,
examples.
white.
So we're gonna sketch a few angles in standard position and state the quadrant and the terminal angles. Okay. So first one we'll do is 36 degrees. So once again, this is a sketch. Now, when you're sketching these, if you have a Cartesian plane, I never sketch the initial arm. It's kind of redundant to draw a line across the x-axis when there's a line there. All right. So 36 degrees, that's less than 90, so I know it's going to be in quadrant 1. And it's going to look something like that. Boom. 36 degrees. Like I said, it's in quadrant 1. All right, my next one, let's do 210.
Wait.
210 degrees.
And C is down there.
Oh.
Yeah. 210 degrees is greater than 180. It's somewhere over here.
Those are some pretty straight lines, Mr. Weber.
Thank you. And that's quadrant 3. And then the last one, 315. 315 is going to come all the way around somewhere like there. Oh, I should do that. Oh, it's too late. That's in quadrant 4. So just so you guys know, quadrant 1, that's for anything between 90 and 0. Quadrant 2 is 91 to 180. Quadrant 3 is 181 to 270. And then quadrant 4 would be 271. Oh, that should be a 1. $360. Okay. Questions about that so far? Right on. All right, moving on. Is that all I got for this page? Next page? Next page. All right, so now we want to determine the reference angles for the following. We've done this before. First one's 130 degrees. Let's go somewhere in here. That's 130 degrees. Now remember, it's the acute angle off of the x-axis. So this is 130, all the way around is 180. That's going to be 50 degrees. Okay. Next one for 300. Am I going too fast?
No.
Slow down.
Okay.
Right now? We're doing that right now.
Mm-hmm. All right, next one is 300. So that's somewhere in here. That's 300 degrees there. So my reference angle coming off the x-axis, right, 60. Good. All right, finding reference angles is going to be very helpful, especially with 2.2. So if you guys know how to work the quadrants, it's pretty straightforward. Question?
Obviously.
Okay.
Oh, it's jazz.
Oh, shoot. Okay. I didn't format that properly, but that's okay. All right, so here we're going to be given an angle in standard position of 40 degrees. All right, we want to determine the value if A, sorry, this should be up here. When I put the Cartesian plane in, it must have moved it around. All right, if it's reflected on the y-axis, and then we're going to reflect it on the x-axis, and then we're going to do a reflection on the x, then or the y, then the x-axis. So we're going to start working with reflections here. So that just means mirror images off certain axes. Okay, so y and x. Okay, so I'll draw the first. Let's draw the beginning one. Standard position of 40 degrees. All right. So there we go, 40 degrees. So reflections are just mirror images off of one of the axes, okay? So if I held a mirror up to the y-axis and shone it over it, it's going to reflect it. It's going to flip it over here onto the y-axis. Basically, you just take the axes and fold them together. So then I'm going to have a line here like that. And that's going to mean this angle here would be the same as this one over here. So that's 40 degrees. So then my total measurement here from the initial arm to the terminal arm would be 140. Okay, so now you're kind of using a little bit, you're kind of have the reference angle and you're working backwards to get the actual angle now, okay? Now, for the next part, for B, I'm going to reflect on the x-axis. So I'm going to start here. I'm going to kind of flip it down along the x-axis, kind of like folding it up and seeing where it touches. All right, that's kind of the way I've always thought of it. So that's off the x-axis. That means I'm going to have an angle here of 40 degrees. So that's kind of my reference angle now. So that means my total angle
It's 120.
Not 120. All the way around back to this x-axis would be 360.
220.
Not 220.
320.
She's a long one. So
It's all right. You're almost there.
you know what I mean.
Yeah. And then now a reflection on the y-axis and then on the x-axis. So I reflect back on the y first, which is this guy here. And then I'm going to reflect down on the x-axis. So that means that I would fold it this way, and then I'm going to fold it down this way, and my angle would then be here. So this would be 40 degrees, and then I would need to get this measurement there.
220.
Good.
There we go.
220. Okay? Any questions about that? All right. I don't think we had to deal with any reflections so far. I don't think there's any in Foundations 20. It's good to get used to it now because pre-calc 30 there are. All right. One last question. That was the wrong button. One last question here. It's always good to end the day on a word problem. All right, Allie is learning to play the piano and uses a metronome to keep time. You guys all know what a metronome is? You got to keep the.
Not quite sound like that.
Oh, it's not that fast.
I am that.
And you got to play 4 beats in the second, right? 4/4 time, or maybe 3/4 time. Now the pendulum arm is 10 centimeters long and moves back and forth from 60 degrees to 120 degrees. What is the horizontal distance the arm travels? Okay, this is on page 82, just in case you guys want to reference the textbook. So you have this pendulum swinging back and forth. With these things, always draw a Cartesian plane and draw your terminal arms. Okay, so basically, start like this. Okay, so I have a pendulum. Right? We know the pendulum arm is 10 centimeters long. Okay? And we know it moves back and forth from a start position of 60 degrees. And then it swings, so it's going to go back and forth. It's going to swing this way, 10 centimeters. and it's going to go a total of 120. Now what we want to do is we want to find the horizontal distance the arm travels. So the horizontal distance is from side to side. So how far did it travel this way? Dun dun dun. All right, so let's break this down a little bit. Let's see what we can solve. I don't know what this is right now. I got to solve for this, so we're going to leave it there. I know that these two lengths are 10 centimeters. I know this total distance traveled is 120, and then this is 60. So from here to here, 60 degrees as well, right? Okay. Now, the information that I gave you guys today was based off of 3 triangles, right? Two triangles. A 45 triangle and a 60-30 triangle. So let's see if we can get one of those. What if I just took this part here and worked with that?
60-30.
Right. So if I redraw that out,
60-40.
this would be half the distance of 60, which is 30. This is 90 degrees. This would be 60. And I know that's 10. And I'm trying to solve for this here. Now, you could use sine, cosine, tangent. Well, you could use either sine or cosine, right? Because you have the hypotenuse. I'm going to go with cosine. I'm going to go with cosine 60 because I know that cosine 60 equals 1/2, right? I know that you guys just learned that today. I don't expect you guys to have that memorized. All right, so I know my opposite over hypotenuse is 1/2. Now I'm trying to solve for this triangle here. I'm going to set up a ratio and do some cross multiplication, okay? I know my hypotenuse is 10, and I know my adjacent is x.
It's 5. It will be 5.
Right. If I do cross multiplication, this way as that way, I'm going to get 2x equals 10. Divide both sides by 2. X equals 5. So this part here is 5. Guess what? It's the same on both sides. That's going to be 5. So the total distance that it traveled was 10 centimeters.
So it's a perfect triangle.
Mm-hmm. Yeah, so this would be an equilateral.
So it'd just be 60, 60, 60.
Yeah, but we didn't know that. Like you
Wow.
can't assume, well, if this is 60, that's got to be 60 and that's 60. You can't do that.
Wow, Mr.
I guess you could have looked at it and seen, well, if that's 30, that's 60, so that makes that 60. That means that has to be 60. You could have done that. But not all the word problems that you're going to get is going to work out that nicely. Okay? So just be prepared for that. Okay? Any questions about that, guys?
No.
So your word problems, if you get any, just remember you got to draw either a 30-60 or a 45 triangle. Okay? And that's basically it. Assignment for today. I'll give you guys some time tomorrow to work on this stuff as well. Just because it's new and it's good to have some practice. So on page 83. Oh, let's change that. Do 3 to 8 for today. I think I have the rest of the assignment on Moodle, but I can't remember now. All right, so start with that, and then I'll give you guys some word problems tomorrow.